if you guys don't mind me, if you can go to chapter 5. Chapter 5 talk about conductor identification, control of lighting devices, bonding, grounding, and induction heat. A quick review, very quick review for some of you, maybe new information for others. So these are the ones that I'm gonna go over. To catch up, I'm hoping I can do 6 today too. 6 talks about GFCI, AFCI, and earth leakage. And GFCI, AFCI might be, I can summarize it in probably 5 minutes, the whole GFCI, AFCI business. So I would like to do that. So a couple of things guys would like to do today. Conductor identification and so forth. As I said, this is mostly for project managers because you're going to be auditing your own or your own jobs before you leave. We love the grounds in the US, and we define all the conductors based on the ground, right? We have the ungrounded conductor, the grounded conductor, and the grounding conductor. The problem, Jeff, when we invade the moon and we inhabit that moon or Mars or any of these places, how are you going to call these conductors? You can't go to the moon and put a conductor and call it grounded conductor. So ground is Earth, unless the ground becomes the moon, redefine the ground as a moon. So anyway, everything is defined by the ground here. So grounded, ungrounded, and grounding. And everybody knows what ungrounded is, the phases, the grounded, the neutral, and the grounding is the ground. Everybody knows these terminology. So these are very, very big terminology that we use. Toggle switches and snap switches used. We'll talk about these one for lighting. Switch proper rating for switches, AC or DC. That's another thing that we would like to touch on in a few here. Operation, type of toggle switches again, and a few things about toggle switches. Toggle switches, guys, AC or DC, that's not a whole lot of deal, honestly. Determine the neutral conductor must be added to a box. In 2011, I don't know if you guys are aware of, in 2011, they start requiring this cycle, bringing the neutral to the box, to the switch. That's, everybody's aware of that, right? Anybody knows that in 2011 code says that you have to bring the neutral to the box. There's some restrictions, some exception for that one. So we'll talk about this. Correct wiring for switches. You guys have wired 3-way and 4-way switches. It's basically single pole switch, double pole switch, 2-way and 3-way switches. And 4-way switches. Yes, sir.
What was that code change?
The code change in 2011, they said if you are, you have to bring, if you're wiring with, here's a restriction. Let's start with the restriction. If you're wiring with cables only, applies to cable wiring only. And if you have a switch, a snap switch that's voltage 120 or 277, so it has to be coming from a grounded system. For example, you can't use 240. Okay, it doesn't apply to 240. It's 120, 277. And that switch is switching a lighting outlet. Then it has to have a neutral in the box.
So they're doing away with California Threeways and...
Yes, that's going to kiss goodbye a lot of wiring that we used to do. Yeah, there's some exceptions though. Some exceptions. Some of the exceptions right now, if the walls are open, and you can obviously you can fish if the top of the wall or the bottom of the wall is open, exception. If all the wall is open, is exception. If you're wiring with conduits, exception. Obviously, because if you wire with conduits, flexible, non-flexible, you can pull a wire. Okay, so that's in 2011 came the change. Bonding devices, bond the box. We'll talk about bonding, guys. This is just bonding a metallic device into the equipment grounding conductor. Inductive heat. This is also the inductive heat. Inductive heat, I can summarize it, Aaron, with one thing. If you have a circuit, you have to pull all the conductors of that particular circuit in the same conduit or cable. For example, I have a 3-phase circuit made out of 3-phase, a neutral, and a ground. Can I put them in 5 conduits or 1 conduit? 1 conduit. That's it. Trench. You trench for a 5 conductor. If you have a 5 conductors for a 3-phase circuit, right? 3-phase, neutral, and ground. Can you trench them in 2 different trenches, or you have to group them together in 1 trench? Group them together. Why? Inductive heat. If you put 1 conductor by itself, guys, a magnetic field, you are creating a magnetic field in the surrounding. You put that conductor in a conduit, you're basically creating inductive heat. What's inductive heat? You're creating a magnetic field that heats the conduit around the cable. Who cares? If you heat the conduit around the cable, we said enemy number 1 of electricity is what? Heat. So this will heating the conduit will increase the ambient temperature of the conductor, and eventually your insulation will fail. If you don't care about the insulation failing, then not a big deal. So that's why we group all the conductors together. Grounded conductor. This is my AKA neutral. When you do the identification, guys, a couple of things about grounded conductor. This has the colors that code allow you to use is white, gray, or continuous white stripes. These are by code. You can't. Now again, you're designers. Who cares? You're going to be a project manager, right? An estimator. So when you're doing grounded conductor, be it 277 system or be it 120 system grounded conductor, or be it any grounded conductor, have to be either white or gray, or white with white stripes. So that's commonly called the neutral, as we all know. And the neutral, and this neutral is always grounded. Almost, here's what the term neutral, every grounded conductor, every neutral is grounded conductor, but not the other way around. Every neutral must be grounded, but not the other way around. You can have a grounded conductor that's not neutral. A good example of this one is corner grounded delta. We'll talk about this one, guys, as we go into commercial. So that's any comments, guys, about the neutral being white or gray or continuous white stripes. Continuous white stripes. Now up to the conductors larger, up to number 6, size number 6, they have to be color coded. Up to conductor size 6, they have to be color coded, meaning white. The whole insulation is white. Now larger than number 6, that will give me what, number 4 and larger. You can actually re-identify the neutral. You can have a black conductor with a white tape on it and use it as larger than number 6 though. Do you see the word? These are for feeders. So if you guys go to a building and you find all the conductors are black and they are re-identified as red, white, blue, and black. So these are the system that you have, and one of them is black and re-identified by a white or a gray. That's okay. Everybody's okay with this one? So up to number 6, they have to be color-coded conductors. Larger than number 6, what do you need to do? They can be re-identified in the field. You see this in feeders, mostly in feeders. Any comments about this? Can I get everybody to give me a thumbs up, Chad? We got this one. Move on. Here's what we're talking about color-coded. This is a 12240 system, as you can see, because we're doing residential. I can't emphasize. You can't believe I had students, guys, in the past. They reach the 5th, they're graduating, and they don't understand when we go to the 3-phase system. When you have, this is single-phase system. When you have single-phase system, there are 2 types of loads you can put on a single-phase system. Line to neutral or line to line, right? Okay, now when you go to 3-phase system, there are 3 types of loads that you can put on a 3-phase system. Line to neutral, right? Phase to A, B, C to neutral. Line to line, and line to line to line, right? 3-phase loads, line to line to line, or line to neutral, that's single phase, or line to line is also single phase, phase A to phase B. Now we are doing residential. Here's your line to line, and here's your line to neutral. So everybody understand what, and anything line to line between the 2 huts will not contribute to the neutral. Your neutral have to be identified as a grounded conductor. As a grounded conductor. The equipment grounded conductor, so everybody knows here's the ungrounded conductor, right? The neutral is the white, and the equipment grounded conductor, this guy, the equipment grounded conductor, the one that grounds the equipment, the green. The equipment grounded conductor by code have to be green or bare, right? And up to size 6, it has to be color coded, meaning green or bare. Larger than number 6, for the equipment grounded conductor, that green, larger than number 6, I can use a black and re-identify it as green and make it an equipment grounded conductor. Can I have thumbs up that we know that magic number larger than number 6 to identify it as equipment grounded conductor? Okay. So that's for the, so we, after larger, up to larger number 6, they have to be either gray or white or continuous stripes of white if they're grounded conductor neutral. If they're equipment grounded conductor, they have to be bare or green. Larger than number 6, number 4 larger, you can re-identify any of the other colors, other than, of course, green and, other than gray and white, re-identify them to be green to be a grounded conductor, a grounded conductor, or grounding conductor. So that will help you guys a little bit on dealing with that. There's something called neutral point that here's this little point called neutral point. If you have a three-phase system, why this point is called neutral point, as long as you ground it here. That's my neutral point. If you have another system, delta, we call it delta. Here's my delta, and I grab a center tab from right here and ground it. This is also a neutral point. Who cares about the neutral point? Out of the neutral point come a conductor called neutral conductor. What's the neutral conductor? It's a grounded conductor. Any question about the ungrounded conductor? The phases, the hots. The grounded conductor, the neutral, and the equipment grounded conductor is the one that you tie to the frame of the equipment. In case there is a malfunction phase to frame, then the circuit breaker will trip. Everybody knows what the function of all these three separate different conductors. The hots for the system to work, right? The neutral is for the system to work efficient, because we don't need the system. I can run hot with ground outside and work it. Hots to make the system work. The white to make the system work efficient. The green is to make the system work safe. Can I have everybody thumbs up that we got that one, Chad? Move on. You keep dwelling on things that we know. Huh? Okay, color coding. There's a color coding, guys, that we use, a couple of color codes. If you have we're talking ROMIX here. If you have a two-conductor cable, as in 14-2 or 12-2 or 10-2 or 8-2, these are all the cables commonly used, or 6-2. If you have a two-conductor, 14-2, 12, or 10, or 8, or 6, you're going to have a black for the ungrounded conductor, a white for the grounded conductor, and a bare. This is ROMIX, and a bare conductor for the ground, for a grounded conductor. Everybody's good with that? Two-conductor cable, three-conductor cable. Guess what they do? The same black still there, the white still there. They add the red. Why do you think they add the red? Then you can use it as another hot, or you can use it as a switched hot, and so forth. Four-conductor cable, which Jeff, you're going to be most likely using it now, because the switches have to have a grounded conductor coming to the switch. So you have to use it. This guy, they give you a black and a red and a blue. So in a single-phase system, and of course the white for your neutral. Here's my neutral here. Here's my ground equipment, grounded conductor, right? And if I'm pulling a three-phase system out of this, that will be phase A, that will be phase B, and that will be phase C. If I'm pulling a single-phase system out of this system, that will be, let me use a blue here, that will be hot 1, and I will use also red hot 2, and the other blue will be used as a switched hot or something else. Any questions about these color coding? We can have more than 4 conductor cables too. Typically 4 conductor cables, MC or AC or NM cable, are the most common. 3 and 4 conductor cables plus 2. Any comments about the color coding for the cables? Now you can, for high voltage, you can get brown, yellow, brown, orange, yellow, brown, and gray cables too. We'll talk about these one as we can get into the three-phase, but that's your residential mainly. This is the most notorious, the famous colors that you're going to have with the cable. Cable re-identification, we'll talk about cable re-identification in a few here. We can re-identify the white to be used as a hot only in cables. Because you learned this with Gary. If you have, we'll show a couple of examples here. We can re-identify. Now, I can't use white as a hot. Can I? White is only grounded conductor. The only exception that they allow to use white conductor in a cable, in a conduit, don't even dream about it. In a cable only, MC, AC, and NEM cable, you can re-identify the white as a black and use it as a supply to the switch, supply of power to a switch. And you can't just use it everywhere. We can use it for supply switch. One application for we can re-identify the white as a black by putting a tape on it, just taping it. One application. What happens if you have a 12-2 and you need to feed a 240? You need to feed a 240 load, right? This is a good application. I have 12-2 cable, and I need to feed a 240 load. So you take the white, we identify as red, and you have your black, and you feed the 240 from both ends you identify. That's one application. The other application for it is supply power to the switch from 14.2, right? You take a 14.2 cable here, you we identify the white, feed the switch with the white as a supply, and the black goes all the way up. Why do they allow you to do that? Safe on copper. Now, with the change that happened recently, you're going to kiss this one goodbye now, right? For the most part, they still, because now you have to bring a neutral to the switch if you're wiring with cable. If you're wiring with cable. And guess what? If you're wiring with conduits like here, you can't re-identify anyway. There's no re-identification. So if this was an MC cable coming here, an MC cable coming here, I can't re-identify the neutral. Everybody understand now why? Because they have to have a neutral here in this box. Any comments, guys, about re-identifying the neutral as supply for the switch? Okay, so that's a couple of things about re-identification. Devices, everything, they get this one in a master exam and journeyman exam. Everything has to be tight in electricity. When we torque, not over tight. We have foot-pound torque that we can torque all these lugs. So this is connection must be tight for switches. If they're not tight, if you don't tighten them, don't over torque them. What are you going to get? Overheat, right? Loose connection, overheat. We have screw terminals is the most common in the devices. These are receptacles, and we have back wiring holes for number 14. If you have number 14, they have a back wiring hose. You guys familiar with that one? You stab them in the back, only for number 14, unstranded. So these are the common ones. When we go to commercial, we kiss these goodbye, the one that you stab in the back, right? And we start using the terminals only. So that's, we'll have a couple of pictures on that one. We'll get into the common configuration. Now, if you graduate from Dunwoody and you don't know the following, please ask me for refund. You know, I was teaching a safety training one time, and part of the safety training is they have to measure the voltage to ground between the neutral and the ground. And the guy asked me which slot is the ground and which slot he was confused between the neutral and the hot on a receptacle like this. Okay, always remember that shoe-looking guy is your ground equipment, grounding conductor, right? This guy. Always remember. Here's how I remember it. These are the most confusing ones a little bit. If you want to remember, if it's hot, the hot side has to be smaller, right? Smaller slot. Why smaller slot? To make it harder for people to stick things into it. Just remember this one. The hot slot has to be smaller. Always. Why? Safety. Because the hot slot is hot at all times. If I plug something, a paper clip on it, and stick my hand in somewhere else and grounded object, I can't get electrocuted. So always remember, the smaller slot is this is the hot. I'm going to call it H hot. And the other one that looks like it, this is my neutral or grounded conductor. Everybody can identify this one? The outlets. This is the most convenient outlet that we use in the US, right? You go to other countries, they use different configuration. I showed you the British, how the British use them. Very similar. All of them look, you're looking at three things almost in every outlet. One hot, convenient outlet, one neutral, grounded, and one equipment grounded conductor. NEMA, our NEMA has multiple configuration, guys. We'll talk about this one. I'll show you a couple of things. So because we want to, you guys can appreciate that when you can drive across the United States and you can go plug any 20 amp receptacle, any 15 or 20 amp receptacle, and you can guarantee that the plug is going to match your plug is going to match the receptacle, right? That's where the NEMA becomes a big deal in configuration. This might not make a whole lot of, because we all grew up with this one, so it's not a big deal. Now imagine having a 50 amp 48277 receptacle. Do you think it should look like this, right? So for all these configuration, NEMA came up with different configuration, guys, for different amps and different voltages. Which means if configuration 1, a plug of configuration 1 cannot fit in a receptacle of configuration 2. Anybody knows why? If I can plug this one in a 240, I'm going to burn my equipment for safety reasons. Okay, so we got that one. We talked about pushing terminal at the end, guys, only for number 14. It's listed only for number 14, solid, not stranded. You cannot use them, shall not use them with aluminum, no aluminum or cover-clad aluminum conductors, and also no stranded. These push in the back, did you guys do them with us? You push it in the back in that little slot instead of terminating on the lugs. You can't use anything that not cover solid, number 14. So there's limitation there. No number 12. So number 12 is also, you can't put them in this configuration. And in the NEC code book, all receptacle must be grounding type receptacle. All receptacle must be grounding type receptacles. And what's a grounding type receptacle? A guy that has a slot like this here, where you tie the grounding conductor to it. Any comments, guys, about this, the receptacles? A couple of these are a quick review on them. Okay, the second one, there's a whole article that talks about receptacles, guys, and switches. This one is 404, talk about switches. They call them toggle switches, the one that you look in the wall here, switches, also known as snap switches. Used for lighting, general use snap switches, we use it for lighting. They come in AC and DC, and there's some restrictions on, can I snap a DC snap switch for DC circuit? Yeah. AC circuit? Yeah. So they can come in AC or DC. Here's some restriction on AC DC snap switches. The ones that we use, guys, are AC switches here. So we have snap switches, either it works on AC or DC, resistive loads only. Inductive loads, you have to cut it by half. You have an inductive load like a motor, you have to cut the load by half. That's bad. And motor load not exceeding the ambient temperature rating, and marked with P for tungsten load for temperature rating too. So there's some limitation. The one, because of resistance, you guys, did you do the experiment with Gary with where you put you try to measure the resistance inrush on an incandescent lamps in the first quarter? You do the inrush on an incandescent lamp, you see how an incandescent lamp, it sucks almost 10 times more current when it starts, because the cold resistance, they call it the cold resistance, is very low. The cold resistance before it heats up and glows, the cold resistance is very high. So this will, if you do this, what does that do to the switch? It will heat your switches. The common ones that use is going to be AC. Here's your AC. You can use them on an inductive or as a resistive load. Bring it on. For tungsten filament ones, the incandescent ones, they not exceed 120. Motor loads, if you're putting them in a switch that you're going to do for me for garbage disposal, when you put them in a garbage disposal, AC, instead of, because they're rated for AC, you can cut them at 80%. For example, I have snap switch here, and this snap switch is rated for 15 amps. So what do you cut with the load that you can switch from it? Inductive load, motor. This is motor. Motor load is 80% of this one is what? 12 amps? 12 amps. Same thing for continuous load. So these are typically going to be using with AC, general snap switches. Re-identification. Here's how we re-identify the neutral with the toggle switches. I can't emphasize, you re-identify only if you're using cables. If you're using conduits, like you're using conduits over here, no re-identification. You guys, so you bring the so you're going to be bringing the power into the light, and then coming here with a 14-2, right? You need hot and supply hot and return to the light, right? The rule says always, you always re-identify. Can you guys see the re-identified white here? Re-identified white. Bring it as a feed to the switch, and the black will be returned from the switch into the light. Can I have a thumbs up that we know that? Okay, now, does this meet the code right now? No, because every switch have to have a neutral. Now you're going to kiss this one goodbye for the most part, right? There will be very limited application where you can use it. But now I can't use that because the code says now every switch have to have a receptacle. So how would you modify this issue? No problem, Chad. I'll bring red here and take my white, and this one will be, get rid of this boy here. Here's my red. So instead of 14.2, now I'm using what? 14.3. Thank you. Using 14.3 and bring my white here. tie it from here and bring it and just terminate it right in here with a log, but a little, not log, wire knot, and stick it right into the box. That's how you have to do it now to meet the code, with few exceptions. Thumbs up, Chad, we know that? Okay, good. So that's, okay, toggle switches, inductive heat. So now moving away, guys, into the inductive heat. Let me summarize. I was teaching a class at 3M, and they told me literally, they walked in one time on one of their projects, and they saw the conduit around the cable glowing, literally glowing, because it was that hot. And the reason for that one, because they were carrying one conductor in a conduit, because the cable is a metallic conduit. It has to be metallic conduit. If you carry one conductor in metallic conduit, guys, you create a heat, an inductive heat. Depending how much current you put in this conductor, if it's 500 kcm, you're pulling 380 amps, you can create a lot of inductive heat to the point where the conduits or the connectors will be glowing because they're hot. So inductive heat is a big deal. How do you solve the problem? Who cares? Always, you pull, if you have a three-phase system, 5 conductors typically, right? 3-phase, neutral, and ground in the same cable tray, conduit, or trench. That's all. To avoid this one. Can I have thumbs up, Chad? We got that one. So when I tell you guys how you're gonna, if you are gonna be creative like the classes before you, and you're gonna be doing 3- and 4-way switches in my 3- and 4-way switches in living rooms in the project, and I'm gonna ask you how are you gonna wire this, and you say, well, I take the neutral from this cable here, and the hot is coming in another cable there. Can you do that? No. If you're bringing the hot and the neutral, they have to be in the same cable. Can I get you? This comes very common, guys, when you do lighting, 3-way and 4-way switch lighting. It screws up. You have a lot of cables, 14.2 and 14.3, that you're going to be throwing around. Keep in mind always, the conductors of that particular circuit have to be grouped together. The circuit, though. So if I have 2 branch circuits, the conductors of branch circuit 1 and conductor branch circuit 2 don't have to be in the same cable or conduit. Okay? Why do they do that? Inductive heat. Here's a good example. Look at this one. I have a fixture. Now I'm feeding this. Can you guys see all the conductors? They're not showing the neutral, but the ground. The ground also will be like this with it, right? Is this cool? All of them are in the same cable, no problem. So 3-way switches. A 3-way switch here. Now it's going to change actually, because this is this one is, we don't have a neutral, right? If we have a switch, we don't have a neutral. Now it's going to change, because you have to have a ground going here and to the ground, and also you also have now to have a neutral for the most part going all the way up to here with cables, right? So all the conductors of the same branch circuit are going together. This is also okay. 3-way switches are notoriously famous, guys. This is okay, because we're not feeding a load. You're just we don't bring the neutral with this circuit, and that's okay. We're not bringing the neutral, right? We're just switching it. Here's what they don't want you to avoid. I have 14.2 here. I pulled and another 14.2, and I pulled the hot in one 14.2 and the neutral in another. Can I do that? Thumbs up. Good, Chad. Okay, so we got over that. Single pole switches. If you don't know how to wire this circuit, guys, my father-in-law is an electronic technician. He wired his house. If you don't know how to wire this one, ask your friend Chad for refund, or let me take you back to our lab so we can wire it. These are piece of cake. Anybody can wire these. Wiring with conduit or boxes. This is the symbol or the schematics that we use, guys, for wiring. Obviously, in the US, do we switch the hot or the neutral? When we switch, do we switch the hot? And you can switch the hot or the neutral, by the way. We switch the hot, safety factor, right? So when you land your switch, when you bring your hot, first you have to bring your hot to a switch. Why? To control it. Then you take it to the load, the light. The neutral can zoom right into the neutral, into the light. Can I switch both the hot and the neutral? Yeah, no problem. But if you switch the hot, you have to if you switch the neutral, you have to switch the neutral and the hot simultaneously. Meaning if you flip a switch, it will turn both of them off. Okay? So this is what we do in the US. We switch the neutral. So here's your circuit coming in here. You bring the neutral to the switch. You switch it, take it to the light, and the neutral continues to go up there. Can I have thumbs up that everybody knows that we switch the neutral, the hot? And if we are to switch a neutral here, what if I decided to put a switch here? Can I do that? Can I switch this? Can I switch the neutral? Yes. Then you need to pull what they call them double pole switches, and you have to tie. They have the handle have to be tied together. Then you're cool. Is this okay? Yes. 2-pole. Is this economical? No. In this application, overkilling. But see how they have to be tied together, though. Thumbs up. We know how to do that, Chad. Cool. Awesome. 3- and 4-way switches. The concept of 3- and 4-way switches, Aaron, my friend, and some of you who did not wire, the concept is they have each of them have 3 terminals. If you understand the travelers, that these two will be the travelers, these are the common. See the common, these are common, these all travelers. When you wire them, very simple. Take the travelers and tie them together. So you take this traveler, tie it to this traveler, and you take the other traveler, tie it to the other traveler. That's the first thing you do, Aaron, right? Take a wire in between, traveler to traveler. And from this side, if I have a fixture, a light here, okay, now I want to ask my friend Andrew, now you're going to decide, do you want to take this side to the light, or do you want to take it to the, and here's the circuit breaker is right here, bringing the power, here's my hot, and here's my neutral, okay? So now I'm going to decide, do I want to bring, your decision, depending where you are located physically, can you bring this one to the light or to the switch? So anybody can, since we're closer here to the light, what do you think the best way to do? Is to bring this boy to the light, right? And if I brought this boy to the light, where do you think this guy have to do that? I have no other option. This have to go to the hot, okay? And I'm not wiring them with, okay? So what am I missing now? In order for the light to work, remember, unless you go tie this to the other end to the ground, like Shad would do in his basement and work in not efficient, not safe, then you have to pull the neutral. So what do you need to do? Then you take your neutral here, and you're going to grab it and feed it to this fixture. That's basically a simple wiring of a three-way switch. Typically, now it's going to complicate the situation here, because the way we're going to wire these, it's going to be slightly different. You're not going to do them the way I did them. You have to basically bring them through cables and conduits. So what you're going to end up doing is you're going to end up, guys, coming from here. Let's just wire it typically here. So you're going to end up bringing this here. So I brought my neutral. Now, Jeff, do I have a neutral with this switch? Yeah, Chad, good to go. Then I'm going to go from here through with the cables and come here. Do I have a neutral, Jeff, in the second switch? Yep, Chad, I do. Then you're going to come from here to here. Now, do I have a neutral with every switch? Yep, I do. Here's cable number 1. This will be 14.2. Cable number, this cable would be what in this case? 14.3. And this cable here would be what? 14.2. That's how you wire them. Does that make sense? Can I get thumbs up, Chad, that we know how to wire that boy? But do you see how you have, based on 2011, you have to bring a neutral to every switch. And I'm not showing the ground. The ground will be with them, of course. Okay, so that's your wiring. If you have a 4-way switch, guys, 4-way switches goes typically with 3-way switches. So here's, I'm going to put two terminals here and a couple of terminals here. So why do everybody knows what the 3-way switch is? Two 3-way switches will give you switching from 2 locations. If you need a third location, you have to add a cross switch like this, or a 4-way switch. Everybody knows that? If I need to switch them, if you need to switch from 100 locations, so two of them have to be 3-way switches. That will give you 98. So that will be 2 3-way switches like this, and the rest of them have to be what? 4-way switches, right? Do you know that the 2 at the end always have to be 3-way switches? The one in the middle, or the ones in the middle, can be the 4-way switches. How do you wire this? Piece of cake. You're going to come with the travelers. So I'm going to go traveler to here. You tie the travelers together from one end, right? And what do you guys think I'm going to do with the travelers here? Travelers together on the other end. Okay, do you see how the travelers, these called travelers? Piece of cake, nothing. And then if I have my fixture here, I'm going to bring this one to the fixture, and I have my service coming, the light coming here. This one to the light. This one to the light. Now to make it legit, Jeff, I need to bring the neutral here and tie my neutral here. Come here, tie my neutral. Just let it sit there. It's not doing anything, right? And bring my neutral here, and put my switch, my neutral. He's not tied to anything. It's just a wire knot. And from here, go to the fixture. Now I have wired the fixture that can be turned on and off from 3 locations. Legit, though. Legit. So take this. How many conductors? This is 14.2. Let's look at this one here. How many conductors do I have here? 14.3, right? Let's look at this one here. How many conductors do I have to? 14.3. How many conductors do I have to? 14.3. Or 12.3 if you want to do 12. Any question, guys? Any question about this?
That was 14.2, right?
Which one? This is
To the left.
14.2. Yep.
To the left. Bottom one on the left.
Oh, this is 14.2, Chad. Where did I get the third reading? 14.2. Did you write 3 here on the board?
Yeah.
Okay. Any question, guys, about these? Aaron? Because you didn't wire. If you want to wire them, the ones who did not wire, guys, if you want to wire them, we'll take it to the labs. The ones who did not wire. Okay. So that's really not a big deal. Okay, 2-pole switches. When do I use 2-pole switches? You use 2-pole switches on anything that's 2-pole load. 2-pole means 2 hots, means 2 phases, right? So I have a fixture. I'm going to burn this fixture at 208. 208, right? I'm going to switch it and burn it at 208. Yeah, the only way you can get 208 in the US is from 2 hots. You can't get 208 from a hot and a neutral, right? Everybody knows that? The voltage hot to neutral is 277 and 120 here. Okay, so then to switch it, you have to have 2-pole. Everybody knows what the 2-pole is. These are pole 1 and pole 2 completely isolated from each other. You land phase A here, phase B here, hot 1, hot 2, and they only flip to each one goes to the other. They don't cross. This is not a 4-way switch here. And you have to open them and close them at the same time. So 1 switch, 2-pole. Have you guys seen wire? It looks like any of these snap switches, except inside it has 2 terminals in, 2 terminals out.
When would you use that?
When would you use that one? You would use it, my friend, on any if you're burning your fixture at 240. In residential, the only place where you end up probably using it if you want to turn a heaters, baseboard heaters. They don't use this technology, but they use a thermostat. It has at the end has a switch, and actually a thermostat has 2 terminals in, 2 terminals out. Baseboard heater commonly used.
Oh, like a line voltage thermostat?
Yeah, line voltage thermostat they call them. You bring it to the thermostat, out of the thermostat. That's act exactly like 2-pole. Now this is in a residential. In a commercial building, you can use, if you want to burn these are ballasted equipment. If you want to burn them at say 480, you can burn them at 480, or you can burn them at 240. Then this snap switch has to be 2-pole. Typically, they don't use them a lot because they use other lighting control system and you can use also the circuit breakers as switches for you.
So sometimes it's 240 volt delta.
240 volt delta to burn the lights at 240. Yeah. Any place where you have 2 hots. You have hot 1, hot 2, phase A, phase B. Or phase A, phase C. Comments, questions? Cool. So that's basically combination wiring devices. You screwed up and you have one only in your receptacle, guys. In your bathroom, you only have 1 single gang box. And by code, you're required to have at least one GFCI receptacle within 3 feet. So here's 1 GFCI. Where do you want to put the switch? Well, that's where the combination wiring devices is, where you can buy a 1 yoke that has a receptacle and a switch on it. Expensive, slightly expensive. Everybody familiar with that receptacle switch on 1 yoke? That's what the combo devices is. Here's my switch here, and here's my receptacle here. Or you can have a neon or pilot lights. Pilot lights, guys, right here, a switch and a pilot lights right here. So when you turn the switch on, the light will go on. You can have an indicating light where you can, when you turn the switch on, the light will go off. So all these are called combination devices. Typically, not a whole lot used, but it comes really handy to use these devices. I promise you, Jeff, my friend, and Jeremy, that we will talk about the tabs. The tabs is a big deal. Tabs is very simple. Take this. I have a conductor, a 20 amp. What do you guys think the 20 amp circuit breaker? This is number 12, right? I have a number 12 here, and then a tab is to come over here and tab it with number 14. You see that this is a tab? Why is it a tab? Because number 14 must be protected with no more than what? 15 amps. I have 12 amps. That's called a tab. Cool? Everybody's okay with that one? Typically, we use them in a bigger system like this. Now go higher. This is a 200 amp feeder. And I'm tabbing this 200 amp feeder. What is it? Let's just say it's 300 kcm, 300 kcm. Instead of number 12, and I'm tabbing this one with number, and I'm throwing these number 1. Why would we use a tab? Cheaper product. You can put a gutter here and tab multiple loads. Can you guys see that? So we'll talk about the tab again. I promise you, we'll talk about the tab rules intensively as we go into the commercial. So. We use timers, guys. A lot of applications we use timers as devices. You know what the timers are? Timers, you bring the in, the out could be multiple zones. You can have two zones of the timer where you turn two things at two different times. Almost all of them have a function of off plus a clock that ticks in order to get you to control certain loads, typically lights, or it could be other loads at a certain time. Turn them on a certain time, turn them off at a different time. So that's what a couple of things about timers. Let me quick here show you, oops, disregard here, Chad. A couple of pictures here. So we went over that one, went over that one. Okay, here's what I wanted to show, guys. These are NEMA configuration. When we go to the commercial project, you're going to find that NEMA, we have a bigger list of NEMAs. So NEMA called this one 5-15R. This is called a NEMA. Oops. This is called NEMA. This is called NEMA 5-15R. R is for the receptacle. Does that make sense? R, receptacle. 15 is because it's 15 amps, and 5 is because related to the voltage 120. They rate them based on 125. They make the receptacle, guys, can handle a little bit more voltage than the nominal voltage. Are you confused? Why do they use 125? There's 120. The nominal voltage is 120. The receptacles, they always rate them a little bit higher than what the nominal voltage for safety reasons, if that makes sense. Okay, so that's how they do them. You know how the slots are, the grounded and the grounding. This boy, look at this one here. NEMA called this is 5-20. So when you see 5, it's 120 system. When you see the 20, it's a 20 amp. When you see R, it's a receptacle. Now, anybody can imagine what the plug name would be? Very easy. The plug that goes with this, the plug itself, NEMA calls it 5-20. Now, Jenny, my friend, guess. This will be R for receptacle. What would you be here for a plug? Start with a plug. P. They use the word P for a plug. That's all. They use P for a plug. So if you see 5-20P, this is actually that one here. This one is called 5. This plug is called 5 dash. In this case, this one is 15. 5-15P. Why? Because it fits into 5-15R. Do you see that? Now you guys laugh at this. When you go to the commercial, industrial, and three-phase, the receptacles, there's so many different configuration of receptacles. And I believe, if I remember right, if they were locking type receptacle like these, you see these are locking type receptacle, you push them and you lock them, they put L in the front of this. So if you put L, this will be, it's locking type, the one that you push, twist. 5, it's 120. 20 is a 20 amp, and P is a plug. and you put L here, 5, L5-20R. This is the receptacle, the locking type, like that one right in the front of you. So that's basically what, this is the 20 amp. This one is, look at this, you guys have seen that. Well, this is 240. Now they use 6 for 240, okay? And you don't have to memorize this. There's a table, NEMA has the table that we use in the commercial all the time. This one is 240. It works for 240, 20 amps instead of 15 amps. These are the most common ones that you probably use in residential. So either 15 or 20, 120, or 15 and 20, 240. Can I have thumbs up, Chad? We know that? Okay, cool. So that's basically what I wanted to emphasize here. The NEMA configuration with the P. There is a beautiful, nice looking receptacle. I know you guys have never seen one before, right? So this, the only one I want to mention that one, since we're doing dwelling now, you have to have the TR. What does the TR stand for? Tamper resistance. All receptacle in dwelling must be tamper resistance. That will run you, you know, the tamper resistance. You can't plug paper clips in the hot only. You have to do the hot and the neutral. So if your son or mine, I'm going to put the hot and well, if somebody's intended to do it, they'll do it. This is meant to protect kids. But some kids who probably will do it. My son would, if he wants to, he'll make it done. So that's one. Different type of receptacle, guys. That can keyed receptacle. We're going to use a lot of keyed receptacle here. We can have a pilot. Pilot, this one, guys, will turn on as you turn it on. Pilot devices. 20 amp receptacle. So there's different configuration of 20 amp receptacles. If you put a receptacle outdoor, what do you need to do for a receptacle in a wet location? Cover it for wet location, right? So we have to do that. We talked about this one, the inductive heat. Same thing for inductive heat, Aaron. You have a 3-phase circuit or a single phase, 120 hot, neutral. When you put them in a trench, you have to glue them together as close. They don't have to be at the top of each other, but you have them side by side as you bury them. Anybody knows why? Inductive heat. They kill the magnetic field. Inductive heat, and they basically, when you put them closer together, their magnetic field cancel each other, so they don't create heat. Okay, this is about the neutral. Remember when we said you're neutral? Okay, you can't end up with a black here. Look at that wiring mess. You have to end up always with a wiring that takes the neutral and the circuit. Can you guys see the conductors with the same circuit and the same conduit? Can I have thumbs up, Chad? We got that one. Now I want to remind you, when we go to the commercial project and we start doing system and say, well, how are you going to pull the neutral? Where's your neutral here? Here's a couple of wiring, guys. Now this is with cables. This is the new change, Jeff. Do you see that now? Now you have to bring your neutral right here if you're doing with cable. Your neutral have to come and terminate. Can you see that? That's based on 2011. Brand new for you. You have to bring a neutral to every switch. If you are wiring with cable, NEM cable, MC cable, AC cable, and this switch is controlling a light, not a garbage disposal, and the voltage for these, this have to be cables for cables only, this rule to apply. And number 2, the voltage have to be 277 or 120 volt. So Jamie means if you are wiring with 240, doesn't apply to it. It has to be grounded circuit, right? And what else did we say? So these are basically the and lights and switching. You're switching lights, not motors, not air handling units. Well, not garbage disposal. Then to apply exceptions. The exceptions, if you have access to the box from the back, the front, the top, or the bottom, then the exception. I guarantee you a lot of people are enforcing it across the board now. Any comments, any questions about neutral with the switch, snap switches? What's the idea behind it? Because people can go get rid of this switch and put a dimmer here, not a dimmer, motion detector. Motion detector, anybody install a motion detector? You bring the hot and you bring a neutral. You bring hot, switched hot, and the switch loop, and you have to bring a neutral for the electronics to cook them, to energize the sensing mechanism in occupancy sensor. What people did before is they tie it to the grounding system because they have a ground. By the way, the grounding conductor and the equipment grounding conductor, you're not supposed to use them, right? But they do the same thing. If you go take a hot and an equipment grounding conductor, the ground, the light will get as bright as you can get it, because both of them are grounded conductor. But we use them differently. We use the neutral to carry the return current, and we use the ground to carry only fault, ground fault. That's all, for safety. Okay, so here's a couple of applications, guys, that you have to do the receptacles. And so these are a few wiring. We talked about these. A couple of applications where you can do three-way switches. Here's where, what I like about this chapter, guys, is if you are not, it gets you all these graphics of wiring, and I know it's very simple for some of you, not simple for others. So this is where you're going to get your travelers all the way to the light, your travelers, and so you're going to get your travelers and your connectors. I don't know if you guys can see these two here. Anybody, can you guys see these are my travelers? These are travelers to travelers, and this is the common, and the common here, one went to the circuit breaker, 20 amp here, or 14 amp, and the other one went to the terminal of the light. Any question about that one, guys? Three-way switches. Again, we're designers, but the worst thing that could happen to you, Kerry, is you go to a job and you don't know how really three-way and four-way switch is wired. There's no reason for that.
You have to re-identify that black traveler as red?
You don't, but it's a good idea. You don't. That re-identification, just to identify workmanlike manner. Workmanlike manner, it's good because now I know that these are traveler for troubleshooting. Okay, so here's another thing. See how they identify them also as a travelers, identify them as travelers. Look at the neutral. I can't emphasize the neutral located with every single one of them. Now you're using 14.4, right? 14.3 here, but 14.4. You guys see that? Under certain circumstances, based where you're sitting, where you're coming, you're going to be using 14.4. 14.4 is in the market, not commonly used, but they're there. Can I get you guys to understand that because of the neutral now you're going to end up with 14.4 in certain bit? If you bring, like in this case, we brought the circuit to the light and we went to switch 1 and switch 2. That's when we're going to be using 14.4. Okay, a couple of applications, guys, sources and power. So what I suggest, again, with cables, look how there's just different scenarios where you bring the power to a light and come from both sides. In this case, we're still landing it with right. We're still using what? 14.4 here, right? We're still using 14.4, right? You need the 3 for the travelers, 1 for the neutral, and of course the ground goes without discussion. Okay, so a couple of four-way switches. Okay, we talked about the light. This is if you have a two-pole circuit breakers. Another application for two-pole circuit breakers, guys, is what if I want to turn 2 circuits on and off at the same time? 2 circuits on and off at the same time. This is mostly commercial, industrial. 2 circuits. I have circuit number 1 here, and circuit number 2 feeding this section and this section. I want to turn them on from one flip switch. Not a good idea, if you ask me. That's when you put one set of lights. These say 5 lights here and another 5 lights here, and you will just turn them on and off from the same flip. And there are 2 circuits. This is circuit number 1. This is circuit number, in this case, using neutral, so this must be circuit number 3. Okay? And flip them, and multi-wire branch circuit, I'm going to flip them at the same time. Then you have to use a snap switch. Double pole. Only if you want to turn them on and off at the same time. And these are the disconnect have to be, probably this will be part of it. In this case, it's required by the code. Because multi-wire branch circuit have to be switched at the same time, right? Talked about this. Okay, a couple of things, guys, pilot devices and so forth, if you don't mind me just touching on these. I don't know if you have wired a switch and The knob of this, the switch knob actually has a light in it. There are two ways you can do it. This one, it's cool. This one is on, indicating light. This one is on when the load is off. Anybody wired any of these? That's inside the switch itself. There's a tiny little resistor. You wired it? There's a tiny little resistor inside the switch. So you don't see it. You just bring in and out. And when you wire, you don't even mess with it. In, out. And the way it works, when you bring the voltage 120 here, it puts this one and this one in series. When you flip the switch open, it puts the two in series. This is a very fat, fluffy, big resistor. So it takes, if the voltage is 120, I'm just going to throw, it takes 110 volt across it. And what's happened to the other 20 volt? Goes, another 10 volt goes here. Do you think the 10 volt will be able to energize this boy? No. So that's how you get them. You put them in series. One of them is so strong in impedance, it takes most of the voltage. The other one takes very small voltage, so that's why it doesn't go on. Now what happens if you shunt it? If you close it here, you shunt it. So all the current is going to go right through it, right? Because the current follows the least impedance. So now you took the 120 all the way and you put it across this fixture. What do you think you're going to get? A lot of light. That's your indicating light. So that's this one is the opposite. This one, it goes on when the lamp is on. When the load is on, so if they use it, some people use it, guys, if you have a lighting fixture in the attic and you have the switch here and you can't see if the lighting fixture is on or off, say, and what you do is when you turn it on, a little light here comes on. That will tell you the light in the attic is on. Okay, everybody's okay with that one? Indicating devices. Cool, but look what the switch turned both of them on at the same time and both of them off at the same time. On or off at the same time. Different type of, we talked about, guys, different type of configuration. You can have three-way switches. You can have all this configuration, switch with a GFCI. I call it, this is screw up, you know, typically. You know, if you put your gang boxes right, you don't want to do that, but it could be also a better way of wiring too. Wiring with conduits. This talks about bonding the ground, guys. You have to bond the metallic boxes right here with your equivalent ground conductor. With switches, a couple of things about switches, same thing. This is just to get you the bonding so you guys can see the box, metallic box. Non-metallic box, who cares? Non-metallic box, who cares? Okay, grounding, there's different ways of taking the ground, right? Look at this here. You can splice all your grounds and you take with one of them. So I'm not going to move through these guys. We can look at your, but this is the image here is just to tell you that you can pigtail. I want to emphasize your metallic box have to be grounded and your grounding slot have to be grounded. So you pigtail all these grounds, different ways of doing it. This is all your hardware that comes to ground the system. The receptacles must be grounded as of 2009, 1999, I believe. This is when we start. Another way of wiring them. Tab rules. Here's where I got caught one time. Jamie, my friend, I wired my brother-in-law's house. And he wants everything 120. He wants everything 20 amps. So I used number 14 cable here, and I came to the lighting fixture. But the switch is bringing number 12 cable. I use it as a home run, and between the switches, I use number 14.2 and 14.3. Wrong. So if this is a 20 amp circuit, number 12, you cannot use number 14. So what do you need to do? Make this number 12. Or change this one to 15 amps. And guess what? Some inspectors won't even allow you to change. They don't buy this. If you're bringing a number 12 here, they say the owner is going to come here and see number 12. It's going to put a 20 amp circuit. So if the circuit is a 20 amp, everything has to be number 12. Cool? Everybody got that one? Okay. A couple of dimmers, guys. Here's a couple of dimmers. Dimmers are on, off. You have line, I don't know if you can see that. You have load and line coming in and a neutral. So you bring your hot in this case, and here's coming in and then coming out and a neutral. And here's my fixture. And you set your timer. This is electronic timer or non-electronic timer, and they will turn it on and off at certain time. And there's an off position. I don't know if you can see that. There's so many types of them now that's unreal. But typically that's what you do. You switch the hot. Some of them can give you multiple lights to switch. Here's an electronic one with a lot of switching mechanism. You have different, you can see have different line here that you can switch from it and program it to turn multiple things. So you can bring hot neutral in, and you can switch 3, 4, 5 things at different times. So when it comes to these guys, I don't know anybody use them, but when it comes to the commercial building, we start using what? We start using lighting control panels with a lot of timers inside them. Okay. This is just a couple of things about home runs and adjustment and so forth. For number 14, we'll talk about trying to tell you each one of these circuits, number of conductor 6, 2-wire circuits. We have number of current carrying conductor. This is just an example how you can do the rating. We'll talk about the rating, guys, at a different time. And this is what I told you guys. This is very important here, where you can re-identify red, black, blue to be white only if you are larger than number 6. And the same thing also, if it's larger than number 6, you can identify them. White and gray can be re-identified as hot only if they're in cables, right? We talked about these. 15. This is the most important small conductors, guys, and landing 14, 15, 12, 10, 30, right? And here's a couple of exercises at the end for you. Here's what I would like you guys to do. Do me a favor, these at the end. I would like you to wire them, sketch them. Just get to practice. I know some of you guys have done them. Practice wiring the 3-way and 4-way switches based on the requirements. So this is, I'm not going to do it for you guys, will do that. There's a few of them in the back that I really would like you guys to do. I'd like you to do. Any comments, any questions for Chad? Any comments, any questions? I would like to give you guys 5 minutes, and because I'm behind, I need to go over the GFCI. I promise no more than half an hour. Do you have a stomach for half an hour of GFCI and arc flash and all this stuff so we can be on track? Cool. Let's take 5 minutes and we'll go from there.